All right, good afternoon, everyone. Thank you for tuning in to Maruf Center for Youth Innovation Teach Moments. And today we have our guest instructor, Samrah. She is a first-year grad student at UWM, and she's trying to get her master's in microbiology. And we are blessed for her to be here today to give a period of instruction, and she's going to focus on algebra basics. And without further ado, I'll go ahead and hand over the mic to Ms. Sam. Go ahead.
Thank you, Jesse, for that kind introduction. So hi, guys. Today we'll be going over some basic algebra involving how to solve basic algebraic equations, and then how to set them equal to, less than, or greater than. And then we'll also touch base on how to solve some multiplication and division, as well as addition and subtraction involving fractions. So to start off, we're going to do some basic algebraic equations. I have a worksheet here that I just found online, and I thought it'd be useful to use. So in the first problem, we have 4x plus 16 is equal to 24. So in equations like these, or in problems like these, the main point is to get the variable isolated on its own. So getting everything away from the x in order to solve. So x is an unknown value that we want to find out to make this statement true, that 4 times that number plus 16 will give us 24. So we start off by isolating any number that is located with the x variable. So we'll start off with subtracting the 16 and doing that from both sides. So we get 4x is equal to 8. And then now we have to get x alone still, so we just divide both sides by 4. By 4. And then our answer is x is equal to 2. And now when we plug this value back in to this number, so if we do 4 times 2 plus 16, this value should give us 24. Same with the problem over here. We have 33 minus 3x is equal to 12. So in this problem, we subtract the 33. So then plug that into your calculator. 12 minus 33 gives us negative 21. So this statement is negative 3x is equal to negative 21. Now we see with the x, we still have a negative 3 located with it. So we just divide both sides by negative 3. And we get a value of x is equal to 7. Because a negative value, a negative number divided by a negative number gives us a positive number. So now when we plug in 7 right here, the value that we should get is 12. And then you can always double check that. It's really important to double check it, actually. Now for this equation right here, we have x minus 6 is equal to 17. What are we going to do first? We're going to add 6. Add 6 to this side as well, and then we get our value of x is equal to 23. Always double check your work, so 23 minus 6 should give us 17. Moving on to the next problem right here, we have 10x minus 6 is equal to 34. What are we going to do here? Add 6 to both sides. And then we get a value of 10x is equal to 40. What do we do next? We just divide both sides by 10. 4 back into here, we should get the answer of 34. Now for the next problem, we just subtract 23. 6x is equal to 6. Now divide both sides by 6. X is equal to 1. So now when we plug 1 back into this equation, the value that we should get is 29. So the overall point of these types of equations is trying to get the variable. So any symbol, whether it be X, Y, A, B, M, N, any letter, any symbol, we need to get that isolated on its own. So first we're gonna go ahead and subtract or add any values that are located with the x and then go ahead and divide. So in this case, again, we have 2x plus 8 is equal to 16. So what do? We subtract 8 from both sides. We get 2x is equal to 8. What do we do next? Since this is multiplied, so this is 2 times x is equal to 8, we have to get x alone. What's the opposite of multiplication? Division. So divide by 2, x is equal to 4. There you go. Moving on, these are a little bit more complicated. So first, what we're gonna do is use the distributive property. So we're gonna distribute this 4 into each number only in this parenthesis. So any number that's in front of the parenthesis, we're just gonna distribute that in. So we're gonna do 4 times x plus 4 times 3, and then just go ahead and solve it the same way that we otherwise would. So this is gonna be 4x plus 3, that's gonna give us 4x. Now we're gonna do 4 times 3, that gives us plus 12. Notice that we're adding it because there's a plus sign right here. So 4 times x plus 4 times 3 gives us 12 minus 2x plus 8 is equal to 28. Now, when we have an equation like this and we see that x is written twice right here, we can go ahead and add these two numbers. So this would be 4x minus 2x, and that will give us 2x. And now we can see that there's a 12 and a 8. We just go ahead and add those two together. So it'll be 20 plus 20 to give us a value of 28. Now we see that x is still not alone. So what we're gonna go ahead and do is subtract 20 from each side. Subtract 20 from each side. And then I'm gonna write this on this side here. 2x is equal to 8. Now what do? We go ahead and divide by 2, x should give us a value of 4. And now when we plug x back into this equation, we should get a value of 28. And it's always important to go ahead and double check your work. Sorry if this is a little bit messy. But now in this case, same thing we're gonna do. We're gonna distribute the 2 to the x as well as to the negative 2. So this equation is gonna be written 34 minus 5x plus, now distribute the 2 to the x as well as to the negative 2. So we're gonna have plus 2x, 2 times negative 2 is negative 4, and this is all equal to 15. Now in this case, we see that there's a negative 5x and a 2x, and we can add those two. So what's negative 5 plus 2? It's negative 3x. So now we're gonna have 34 minus negative 5 plus 2 is negative 3x. Minus 4 is equal to 15. Now we see we can add 34 and negative 4 together. So 34 minus 4 is 30. So we're once again just combining like terms. Okay, so now we have 30 minus 3x is equal to 15. Subtract 30 from each side, subtract 30. We get negative 3x is equal to negative 15, because this is 15 minus 30. That'll give us a negative number. So that means that we have less, or we actually don't have this value. This is negative, so we don't have it. Now we just divide by negative 3 on both sides in order to isolate the x variable. Divide by negative 3. Now negative 15 divided by negative 3 gives us positive 5. Because remember, a negative divided by a negative is equal to a positive value. One more or two more sets of problems. So in this case, we have right here. We're going to have 9x minus 6x, because we're just distributing the 6 in. So minus 6x minus 12, because negative 6 times 2 is negative 12. minus 6 is equal to 12. What can we do here? We can combine like terms. So 9x minus 6x gives us 3x. And negative 12 minus 6, so it's a negative minus a negative, or minus a positive value, but still going to give us a negative value. So negative 12 minus 6 gives us negative 18. And this is equal to 12. Now what do? We go ahead and add 18 to both sides, and we get 3x is equal to 30. Divide by 3, we get a value of 10 for x. So now when we take 10 and we plug it back into this equation, we should get an answer of 12 right here. Now for the next one, same thing. We're just going to use the distributive property and distribute the 2 to the x as well as the negative 3. So we have 10 plus 3x plus, so we're going to have a positive 2x value here. It's 2 times x, so 2x minus 6, because 2 times negative 3 is equal to 6. So minus 6 is equal to 29. And then what can we do? We can combine like values again. So we can do 3x and 2x, add those together, and then 10 and negative 6, add those two together. So we get, just to start off, it's 10 minus 6, we get 4, and then 3x plus 2 next. We subtract 4 on both sides, so we get 5x is equal to 25. Now we're trying to get x alone, so just divide both sides by 5. And what do we get? We get x is equal to 5. Now, when we plug this value back in, we should get an answer of 29. So for these questions down here, we are given an x value. So this is involving two variables. We're trying to solve for what x is. So we can see that there's an x and an y. This just stands for an unknown number. So we don't know what this number is. We're given the y value, but we're not given this number. So this is what we're essentially trying to find out. When you're given a problem like this, you want to plug in the y value. So plug in 4 wherever you see a y, and then solve for x. So in this case, we have 7x. We have 7x minus 3 plus 4y is equal to 27. We know that y is 4. So we're going to rewrite this equation, minus 3 plus 4. Now 4y means that 4 times or multiplied by this number. So whatever value that is, which we're given is 4. So 4y means 4 times 4, which we're given right here. So I'm just going to put a 4 right here. And this is all equal to 27. So what is this? We do 7x. We're going to go ahead and combine like terms. What's 4 times 4? It's 16. 16 plus negative 3 gives us 13. This is equal to 27. What do we do next? We add 13 on both sides. So that's 27 plus 13. This gives us 40. So 7x is equal to 40. And then divide both sides by 7. So 40 divided by 7 gives us a value of 5.7. So x is equal to 5.7. And now when we plug this value back in, we should get a value of, or sorry, I made a mistake here. This is actually positive 16. So we're going to subtract 13 on both sides. 27 minus 13 gives us a value of 14. So this will actually be 14x is equal to 7x is equal to 27 plus 13. is equal to 4x. So for 4, we get 5.7. Okay, going to the next problem. We have y, which we're given as 2, and then we're solving for x again. So we're going to have 2, plug in 2 for wherever we see a y. So 2 times 2 plus 8 plus 5x is equal to 27. Now we're going to go ahead and solve this. So we have 2 times 2 is 4 plus 8 plus 5x is equal to 27. So 4 plus 8 is 12. And then we have plus 5x is equal to 27. Now we want to get like terms on one side, so we want to isolate the x value. So what are we going to do? We're going to subtract 12, and then 27 minus 12. So we're going to, this value now says, or this equation now says 5x is equal to 15. Divide both sides by 5. Divide this side by 5. We get x is equal to 3. Okay. And then so forth. So this is essentially how you solve an algebraic equation. And it's really important to go back and check your work because it's really easy to make basic mistakes. So we talked about isolating the x value. So having the x value by itself. So if I go ahead and rewrite one of these equations, if I have 33 minus 3x is equal to 12, my first step is going to be to remove anything that's located with the x variable. So in this case, just subtracting 33, and then now we rewrite this equation as negative 3x is equal to, so you can use a calculator if this math is a little too difficult for you. You get negative 3x is equal to negative 21. Now we see that this is negative 3 times x. There's a invisible little multiplication right here. So this is negative 3 times x is equal to negative 21. What are you going to do? We're going to divide by negative 3, and then what do we get? We get x is equal to positive 7. And that's because a negative divided by a negative gives us a positive value. Now that we know how to solve algebraic equations, we're gonna set these equations equal to or less than. So these types of problems are dealing with two separate equations, and we're trying to essentially figure out if these two equations are equal to each other or if they're less than each other. So if this equation is less than this equation, or if this equation is greater than this equation. So the way to do this is to figure out what the x value is here, because we don't know if this is like a 1, a 2, a 3, or 4. We don't know what value this x number is. So how to go about solving these equations are, fresh sheet of paper. So you have to essentially solve each side. So in this case, we have 5x plus 4. What does that equal to? We have 5x plus 4. Essentially, we think that it's equal to 0 because we don't know what the value is. So 5x plus 4 minus 4, 5x is equal to negative 4 divided by 5 divided by 5. So negative 4 divided by 5 is equal to negative 0.8. So, or in this case, sorry. So once again, it's important to read the directions. So here we're actually given an x value. We're not solving for x. We're given the x value. So it's going to be, we have 5x plus 4, and then we have to figure out if this is equal to, greater than, or less than 3x plus 15. So the method to solve this is we're given the x value. So we're just going to plug in x wherever we're going to plug in 3 wherever we see an x. So this is going to be 5 or right in on here. So just plug in 3 wherever we see the x. So this will be 5 times 3 plus 4. What does that equal? 5 times 3 is equal to 15 plus 4. So 15 plus 4 is equal to 19. Okay? So this side is equal to 19. Now we're going to solve for this side. We know x is 3. So what we do is plug in 3 wherever we see an x. 3 times 3 plus 15. And then we do 15 plus 9 because 3 times 3 is equal to 9. So 9 plus 15. This is equal to 24. So which number is bigger, 24 or 19? Obviously, it's 24. So we're going to have the bigger side of this symbol facing, so the open side of the symbol, which means that this value is greater than this value. So this small angle right here indicates that this side is less than. So this number is smaller than this number. Same deal on the other side. We are given that x is equal to 3. So once again, we just plug in 3 wherever we see an x. So 2 times 3 plus 3. What is this equal? 2 times 3 is equal to 6 plus 3 is equal to 9. Now on this side, we're given x is equal to 3. So we're going to plug in 3 wherever we see x. So 6 times 3 minus 5. So what's 6 times 3? It's 18 minus 5 gives us a value of 13. So 18 minus 5 is equal to 13. Now, which side is bigger? 13 is 13 a bigger number or is 9 a bigger number? 13 is obviously a bigger number. So we're going to have the bigger side of the less than or greater than symbol facing the bigger number. So the bigger opening or the bigger side of the angle faces the bigger number, and then the smaller side faces the smaller number. Same deal. We're going to solve a couple of more. So here we have x is equal to 3 still, and then we're just solving the equation. So x plus 23 and then 5x minus 4. So here we have 3 plus 23, and then here we have 5 times 3, which gives us 15 minus 4. So what does this number equal? This equals 26, because 23 plus 3 is 26. How about over here, 15 minus 4, that equals 11. So in this case, which number is bigger, the 26 or the 11? The 26. So we'll have the bigger side of the symbol facing the 26. So just the importance here is having the smaller side of the angle facing the smaller number, and then the bigger side of the angle facing the larger value. Same deal over here, 6x minus 2. We're still using x is equal to 3. So always plug in 3 wherever you see an x value. So for here, we'll do 6 times 3 minus 2. So 6 times 3 is equal to 18 minus 2 gives us a value of 16. And then 4x, plug in the x for the value next to 4. So 4 times 3 plus 4. This is equal to 12 plus 4. This is equal to 16. So which number is bigger here, 16 or 16? They're both equal to each other, right? So we just put an equal sign in the middle. So that's basically how you go about solving the less than or greater than or equal to sign equations. And then here we have a couple more down here. I'll just solve a couple of these and then we can move on to the next lesson. So in here, we're given x within value of 7. So we're going to do 3 times 7 minus 7. And then over here, we're going to do 4 times 7 minus 14. And what do we do next? We do 3 times 7, so it's 21 minus 7. What does that give us? It gives us 21 minus 7. Gives us 14. And then over here, we have 4 times 7 was 28. So this is going to be 28 minus 14. What does that equal? Equals 14. So which value is greater, 14 or 14? They're equal to each other, so you just do an equal sign. How about over here, 6 times x minus 18? What is that? What relationship is that with this equation? 4x minus 4. Do the same thing, plug in 7 for x. So you have 6 times 7, which gives you 42, minus 18. This gives you a value of 24. And then over here, you do 4 times 7 minus 4. So 4 times 7 is 28 minus 4. What does that equal? Equals 24. So what are these two equations? They're equal to each other. One more. So how about this one where you have x plus 7? Same deal, just plug in 7 wherever you see x. So this is 7 plus 7 plus 7. This equals 21. So 7 plus 7 plus 7, that gives you 21. And then 5 times 7, that gives you 35. So essentially, this side is bigger than this side. So we place the greater side of the symbol on, facing towards the bigger side. So now we know how to solve algebraic equations as well as set them greater than, less than, or equal to each other. Now we're going to deal with solving fractions. So adding fractions, subtracting fractions, multiplying fractions, and dividing fractions. Sometimes that can be a little difficult to grasp at first, but as you practice more and more, it becomes easier. So looking at the first equation, we have 2/5 plus 4/10. Now, just looking at this here, it'd be very difficult to solve this. So what we need to do is get a least common denominator. So we need to get a number that both 5 goes into and 10 goes into evenly. So what number does 5 and 10 go into evenly? It's the value of 10. So when you're adding fractions, essentially, the main thing is that the denominator needs to be the same. So the top number is the numerator, and the bottom number is the denominator. We have to make sure that the denominators in both fractions are the same in order to make it easy to solve. So in this case, we have 2/5 plus 4/10. These don't have the same denominator. However, what is the least common denominator, least common number that 5 and 10 both go into? It's 10, right? So we have to do something to this side of this fraction in order to get the denominator to a value of 10. What are we going to do? What number times 5 gives us a value of 10? It's 2, right? So what we have to do is multiply this number by 2 on the top and 2 at the bottom, because whatever you do at the bottom, you have to do it to the top too. So now what do we have? We have a value of 4/10, right? Because 2 times 2 is equal to 4 and 2 times 5 is equal to 10. So 4/10 plus 4/10 gives us 8/10. And then if you want to go ahead and simplify this equation, that can be done so by finding a number that both 8 and 10 go into evenly, which is 2. So 8 divided by 2 gives us 4, and then 10 divided by 2 gives us 5. So divided by 2, divided by 2. This is just if you're trying to simplify the equation. So you have 4 divided by 5. This is the simplified version of the fraction. So going to solve, essentially to solve addition fractions, the main point is to make sure that you have a least common denominator. So a denominator that both 10 goes into evenly and 4 goes into evenly. So in this case, for 9/10 and 3/4, which denominator, which number can we use that 10 goes into and 4 goes into? It's 20, right? So we have to do something to this fraction to get the bottom value for 20. So what do? We multiply by 2, because, right, 2 times 10 will give us 20, and then same with the top. Multiply whatever you do to the bottom, you have to do to the top. What about this side? What can we multiply this number by to get the denominator to be 20? It's 5, right? So whatever you do at the bottom, you have to do to the top. So now when we rewrite these both fractions out, we get 18 over 20 plus 15 over 20. And this gives us a value of 18 plus 15.
We're trying to get a boost.
This gives us a value of 33 over 20. So the main thing to remember here is, our main idea is that when you're adding fractions, you have to make sure that the denominator is the same. So multiply by whatever number it takes, and make sure you do it, whatever you do to the bottom, do it to the top as well. But you just have to make sure that you get a least common denominator. So least common. This is very important when solving addition fractions. Same deal goes with subtraction. So when you have a fraction that involves subtraction, you have to do the same thing. Make sure that you have a least common denominator. So between 3 and 5, or sorry, looking at this problem, between 10 and 2, which value is it that 10 goes into evenly and 2 goes into evenly? It's 10, right? So we can leave this fraction as it is, but this fraction will have to change. So we have 9/10 minus, what number can we multiply this value by to get 10? It's 5, right? So whatever you do at the bottom, you have to do to the top. So when we multiply this across, we get 1 times 5 is equal to 5. So I'm going to write this down here, over 10. So you go about solving it the same way. Once you have the same least common denominator, you just go ahead and solve it going across. So 9 minus 5 is equal to 4. And then just keep the denominator the same. So 4/10, this can also be simplified to 2/5. So whenever possible, make sure you simplify your fractions. Now we're going to do one more problem. So this value is 2/5. Now looking at 3/4 minus 1/2, we have 3/4 minus 1/2. What value does 4 and 2 both go into evenly? It is 4, right? So we can just multiply this side by 2 and this side by 2 to get 3/4. So when we rewrite this out, it'll be 3/4 minus 2/4, right? Because 1 times 2 is 2 and 2 times 2 is 4. So now our new equation, or our new fractions, are 3/4 minus 2/4, and this gives us a value of 1/4, because 3 minus 2 is 1. So 1/4. Now, multiplication is essentially really easy because you can just go straight across, right? So for addition and subtraction, we have to make sure that we have the least common denominator. So for all of these, we have to have the least common denominator. So this is important when you're solving for addition or subtraction. You have to have a denominator that both values go into. However, for multiplication, it's much easier because we can just multiply across. So you just have 1/2 times 1/3. What do? You just do 1 times 1, multiply across, and then 2 times 3. What does that equal? 6. Done. Same here, multiply across. 3 times 3 is what? 9. Divided by 4 times 5. 20. Done. This one too. Takes like no time. 1 times 4. 4. 10 times 5. 50. You get 4/50ths. Easy. Done. And then for division, that's actually, you can go ahead and simplify this too if you want to 2/25. So yeah, main deal again. For multiplication, you can just multiply across, but for addition and subtraction, you need to make sure you have the least common denominator. For division, my little brother actually showed me or taught me a cool trick to remember how to do division. So he said it's same, change, and then flip. So keep this value the same whenever you have division, dividing fractions. Keep this value the same. Change this. So what's the opposite of division? It's multiplication. So so same, change, flip. So that means flip this fraction. So it essentially says 5/2 rather than 2/5. So when we rewrite this, it'll be 1/3 times, right? Because we changed the division to a multiplication, and then we just flip this value. What does that give us? 5/6. So once again, say keep this value, change this value, and then flip it. So we have 9/10 times 2/1, right? Because we just flipped that. 9 times 2 is equal to 18. Divided by 10. This essentially just gives us 1.8. But you can keep it as a fraction. So this is essentially how you want it, or we can further simplify it down to 9/5. And then last one right here, 4/5. So change this value and then flip this value. So 4/5 times 10/7 is equal to 40/35. And then you can further simplify it. So that's the end of today's lesson. What we basically went over is how to solve algebraic equations. So remember, the importance is to have isolate x. So whenever you see an x value, you just want to get it alone. So either subtract whatever is next to it, or multiply or divide. The main point is to get x alone. And then for the less than and greater than problems, you pick whatever side is bigger than or greater than, and then the side that's less than, and then just use this symbol to face towards the greater value, and then the smaller side of the angle to face the value that is less than the greater value. And then for fractions, for multiplication or for addition and subtraction, you have to find the least common denominator. And then for multiplication, you can just divide across. And then for division, remember, keep the first value the same, change the division to a multiplication, and then flip the fraction. So yeah, that's the end of today's lesson. And then we'll be back with another video dealing with some other algebraic equations or problems that will be useful to you guys. Thank you.
All right, everyone, let's go ahead and thank Sam for giving us basics of algebra. And we thank everyone for tuning in. Next on the agenda, we'll be back online at 3 o'clock with myself, Jesse, and we're going to go over mentoring through chess. So we thank everybody for coming through. And everybody be safe out there, keep the distance going, and be safe.